Greetings DataStax users. This video is for your eyes only. I'm a commander with MI6, here today to share with you intelligence on recent database intrusions. The specter of hackers looms over all internet users, but for operators responsible for database security, they can be particularly frightening. They scare the living daylights out of me. This recording will illustrate how easy it is for hackers to infiltrate databases with exposed attack surfaces, and then show you how to configure basic Linux firewalls to secure your servers. First, playing the part of the hacker, we'll telnet to an unprotected DSE host on the CQL binary protocol port. The telnet command to port 9042 is successfully opened, and I can send a command to the server to see how it responds. Even a not very clever hacker can deduce from the specific port that responded and the contents of the error message that this is either a Cassandra or DSE node, and move on from telnet to a more sophisticated attack. So, let's take a look at what a more sophisticated hack might look like. Using a few Google searches on the port number and the text of the protocol message will quickly lead our hacker to download Cassandra or DataStax Enterprise. Then, the hacker can connect directly to the node using a real client tool like CQLSH, for example. Now, the hacker has free rein to explore this completely unsecured database. It's worth mentioning that encryption, authentication, and authorization are additional security measures to consider, but the focus of this video is on the attack surface itself, the network ports. It doesn't take long for a hacker to learn enough to do some damage. First, reviewing the available key spaces, and honing in on the non-system key spaces, in this case, the killer app key space, as a likely location for high-value data. This is quite the find, as the hacker has identified a database hosting data for a secret American government initiative, codename Northwinds. Then, the hacker examines the tables in that key space and decides to take a closer look at the customer's table. It's easy to see the data in the customer table contains sensitive personal data, credit cards, addresses, American social security numbers. Our hacker has established his view to a kill. Copy the sensitive data out and use that to extract hard currency from the victims. Blackmail and extortion with Bitcoin are unfortunately a frequent occurrence with database breaches like this. Finally, our hacker has only to drop the key space to complete his crime. The simplest way to avoid falling prey to attacks like this one is to keep unsecured database ports off of the internet. Here, we'll show you how to do that using the Linux firewall called IP tables. This is just one possible firewall that can be used, but hopefully a practical example configuration will be illustrative. First, let's look at the nodes in our cluster, which are laid out in the etc hosts file. The node that we're on now is the app server. This is the node that the database will expect to have connect to it as a client. The other nodes listed here, Node 0, Node 1, and Node 2, all have two IPs assigned. DataStax Enterprise is configured to use the 172 address space, and so those are the ones that we'll secure with the firewall. To begin the process of firewalling off our database, we'll SSH to the first database node, Node 0. Then, we issue a series of IP tables commands to designate what traffic is allowed to pass through to our database ports and what traffic is not. Let's take a closer look at the IP tables commands that we're entering. We start with sudo because we need super user permissions for this task. Then, the IP tables command itself. -A indicates that we're appending to the input rules. -P states that this rule is for TCP protocol traffic. --D port specifies the destination port 9042. -S indicates that the source IP that is allowed for this rule is the application server's IP. And finally, the -J tells the rule what to do if these conditions are met. In this case, accept the traffic. And next, we configure similar rules for the other database nodes in this cluster. In addition to the port 9042 traffic, we'll need to tell the database cluster nodes that they are allowed to communicate with each other on port 7000, commonly referred to as the storage port. Finally, we tell the firewall to drop other attempts to connect to these ports. Next, we'll connect to the other nodes in the cluster and configure the firewall rules on those nodes as well. Now is a good time to mention that the rules we've specified so far will be lost at reboot, so it's important to put these rules into an etc.rc.local file or similar startup configuration script. Now that we've configured our firewall, the hacker will have a very different experience probing our defenses. Let's take another look at that attempt to telnet the CQL protocol port. As you can see, there is no response. The request just sits there. Similarly, an attempt to connect to that port with CQLSH times out quickly. We've managed to make the job much more difficult for the hacker, who at this point is likely to move on to easier targets. All the money in the world is not enough to buy back the trust of your customers, though some have seen reasonable success with free credit monitoring and generous gift cards. We hope that this video will help you avoid the dangers involved in operating internet-facing databases, and DataStax Enterprise in particular. Remember, these are only first steps in security. Visit docs.datastax.com to read up on DSE Advanced Security for encryption, authentication, and authorization with Kerberos, Active Directory, and LDAP, and role-based access control. Also, consider using OpsCenter 6.0's Lifecycle Manager as an easy way to deploy DataStax Enterprise clusters that are secure by default. Thank you for your time. And now, if you'll excuse me, I hear a vodka martini being shaken that I feel compelled to investigate.